Hey Tube, welcome back. Problem number 34. Find first and last position of element in sorted array. So given an array of integers called nums sorted in non-descending order, we need to find the starting and ending position of a given target value. If target is not found in the array, we return -1 and -1. You must write an algorithm with O of log n runtime complexity, so we will have to solve it in a binary search with a binary search algorithm. An example for us to understand the problem: if we have this array 5, 7, 7, 8, 8, 10, and our target is 8, we will return the first occurrence of 8 and the last one, so it will be number 3 and number 4. Here, if the target is 6, but we can find any, we return -1 and -1. If the target is 0, the array is empty, we return -1 and -1. So how can we solve this problem? We solve it by using a binary search. Okay, so before we think about that, we need to implement a binary search, but we need to um, create a helper function to help us, like we created an inner function that will perform a modified binary search to find either the first or the last occurrence of a target in the array. The trick here that we're not only looking for the target, we need to look for the first occurrence and the last occurrence. So we will change the binary search. So we will create a function. We call it find. Let's call it find boundary. And this function, it's an inner function, and the inner function here perform a modified binary search to find either the first or the last occurrence of the target in the array. Okay, it will take three parameters. First, nums, which is the sorted array to search within, and it will take target. It's basically the target, the value, basically the value to search for, and we will have a find first. And this one is a flag. It's a flag, it's a true or false, it's a boolean. Basically, true means search for the first time, which is leftmost occurrence. False mean search for the last time, that means it was rightmost occurrence. Okay, so we have our function now. We create a variable, so let left equals 0. We initialize left, which left pointer to the beginning of the array, and we had another pointer let right, which will equals nums nums the length -1. This is a boundary index. Basically, we initialize right here pointer to the end of the array. After that, we create the boundary index. This boundary index will store the most promising index found so far. It will initialize to be -1, indicating no target found yet. I will perform a while loop. Left is smaller than or equal right. So we perform a binary search as long as the search space is valid. The loop continues as long as left pointer is not past the right pointer. And after that, we say let mid equals left plus math dot floor um, right minus left divided by 2. So here we calculate the mid index. We're using math.floor for preventing any math.floor plus left to prevent potential integer overflow for every large left on target, each large left and right values. Though for typical JavaScript array size, left plus right divided by 2 is usually fine. Okay. So we will start the comparing logic now. So I would say if nums of mid equals target, if that was the case. So we have some cases. Case one, the element at mid is equal to the target. This mid is a potential answer for our boundary. So we will update the boundary to be mid. So we have two cases. If find first, so if find first is true, like if we are looking for the first occurrence, we have found a target at mid. It could be the first. To ensure we find the absolute first, we try to find an even aerial occurrence by narrowing our search to the left half of the current segment. So right will equals mid minus 1. Else, if we are looking for last occurrence, we have found target at mid. It could be the last. To ensure we have found the absolute last, we try to find an even later occurrence by narrowing our search to the right half of the current segment, including mid minus 1. So left will equals mid plus 1. Okay. If nums of mid doesn't equal target, so else if nums of mid is smaller than target. Here, this is a second case. The element at mid is less than the target. Since the array is sorted in non-descending order, the target, if it exists, must be in the right half of the current discard mid at and everything to its left. So we will do left will equals mid plus 1. Else, this is the last case. This is case 3. Basically, the element at mid is not equal to target, is not smaller than target. That means we have only one thing, which is it's bigger than target. So the element at mid is greater than the target. The target must be in the left half of the current segment since our array is sorted. So we discard mid and everything to its right. So and everything to its right. So right will equals mid minus 1. Okay, so we finished this function that has all the functionality we need. So after that, we will call this function two times. First, we will find the first leftmost occurrence of the target. So we call our helper function. So we create a const here, const first p, let's call it first position, which will equal find target, and it will take three parameters, nums and target and true for first find first. And we will make a quick check because we need to check if the target was found at all. If the first position is -1, it means the target does not exist in the array at all. So if first position equals -1, we return array with -1 and -1. So after that, we start the second step. So we will find the last rightmost occurrence of the target. We call our helper function with false for the find first. This call is only made if the target was confirmed to exist. So const last position which will equals find this everything, but this one should be false. And after that, we return first position and last position. Let's run. Why? Uh, Undefined and undefined. This doesn't make any sense. Um, I forgot to return. Yeah, it worked. Submit. Yeah, it works. It works. It works. Actually, the trick is to play with the found boundary. This is a trick, but it's still like an easy binary search algorithm to solve. So that's it for this video, and thank you for watching it.